Hey guys, welcome to day 5 of the Advanced Robotics Summer Camp. Now that we have a simple understanding of how to CAD the robot, build the robot, and wire the robot, let's get into how to get the robot to actually start moving. But before we start coding the robot movement, let's go over some things to get a solid foundation of what programming is like in robotics. So the agenda for today is to explain how programming is like in robotics, learn about the various programming languages used, learn about the software we use to program a robot, and learn how to drive a drivetrain using tank drive controls. Programming is when you write instructions for the robot to follow. More specifically, we use it to get the robot to move around and manipulate objects, such as moving a sky stone to the foundation. Programmers code the hardware of the robot. For example, if this button on the controller is pressed, set the servo position to open, or if this button is pressed, close it. A programming language is a software used to tell the robot's control system what to do. Each of the 3 programs in Middleton use different languages and application softwares. VEX uses Robot C, which is specific to X. They code on VEX code application. FTC mainly uses Java and a more complicated language called Kotlin. They code on Android Studio. FRC uses Java and C/C++. They code on IntelliJ for Java and Microsoft Visual Studio. Now that we got that out of the way, let's learn some basic programming terms essential to understanding the robot code. A variable is a component that stores data in the program. It can store data for a number, word, referred to as strings, or even motor data. Variables are useful for organizing your code and make it readable for other people to look at. A class is a file that stores methods and variables. In robotics, classes are used to store functions and variables for a certain mechanism or op mode. A method is a block of code used to perform a single related action. For example, you can use a grab block method so that the robot can grab a block. So this is an example of a method. It has public, static, double, harmonic. Double is the type of variable that it's going to return. An op mode is a class provided by FTC. This class has data for controllers and methods we can use for running the robot. The init method is used to initialize all the hardware. You're essentially just mapping out where everything is on the robot. The loop method constantly checks during the teleop which joystick buttons are being pressed so it can apply the robot movement. The most important parts of the op mode class for the tutorial are gamepad 1, hardware to initialize your hardwares, telemetry used to show data to the phones, and init and loop methods. So that's it for the background knowledge. Now we're going to get to actually program the robot. So now let me show you how to drive the robot using tank drive controls. So right click on this package, you go to new, and then you go to Java class. Then let's just call it teleop. And then now that we have the class, you want to do something called extending. And what this allows us to do is use methods directly from another class. And we want to use methods from the alt mode class. And those methods are init and loop we talked about in the presentation. So first, we have to define the motors, like how many motors we're using. And since we're using 4, we're going to declare 4. But on our current robot, we have 2 motors, so I'll just use 2 motors. So we have to say private DC motor, left and right. So these are variables which has which lets us use methods such as powering the motor and things like that. And then when you go to the init method, we say left is equal to hardware map dot DC motor dot get, and then inside it you say left. So what this is what hardware map is doing is trying to find the motor that's connected to a certain port and that's assigned to the word left on the robot controller phone, and so it assigns whatever that motor is connected to this variable, and then you do the same thing for the bottom, for the right motor. And then you have to do another thing called set direction, and you say direction dot reverse. So what this is doing is, technically, before we reverse the direction, if we set the power to 1, one of the wheels will go backwards and the other wheel will go forward, just because of the way the motors are positioned on the drivetrain. So you have to reverse one of the motors, and if it and after reversing it, if you set both motors to a power of 1, then they should be going forward. But if it goes backwards, then you have to reverse the right motor, and you can just do it by copying and pasting the word right over here. And there's something you want to do is you have to say left dot set 0 power and then brake. So what this is doing is that when the motor reaches a power of 0, it instantly stops, because an issue that arises when you use the default 0 power behavior is that when you set the power to 0, it gradually slows down instead of immediately stopping. So if you set it to the brake mode, then it's gonna stop immediately when the power is 0. And then you do the same thing for the right side. And then that's how you initialize all the hardware in this one init loop, init method. So now we're going to go to the loop method, and this is where we're going to write the code for making the robot move. So here I'm going to define some variables. Left Y, which is the gamepad. The gamepad 1 is the driver 1 controller. So gamepad 1 dot left stick Y, which is the up and down movement of the left stick. But the reason why I have to make it a negative is because when you move the left stick up, it returns a negative value. But so this means that the robot would drive backwards. But if you move the joystick up, we want it to go forward, right? So by adding a negative, it makes the entire variable into a positive, so that the robot moves forward when you move the joystick forward. Then you have another variable, which is right X, and that is gamepad 1 dot right stick X, which is the left and right movement of the right stick. And that's what you do for the joystick variables. And now you have the actual power variables, like how you move the robot around. So you have left power, and you say left power is equal to left Y minus right X. Then you say right power equals left Y plus right X. And what this is doing is that, let me change this actually. For our robot, it's a bit different. But what this means is that, let's think about it in this perspective. Before you add the right X, you just have left Y. So this means that if you move the joystick forward, it's going to move forward. And if you move the joystick backwards, the robot's going to move backwards. And then let's say for this scenario, you have just the right X included, the plus right X and minus right X. So think about it like this. Move the joystick to the right, that means the joystick has a value of 1, which means that this would be a positive 1 and this would be a negative 1, which means that the left motor would be moving forward and the right motor would be moving backwards. So it's going to be turning right, which is exactly what we want. So if you add in the left Y and right X terms together, then you get the left power and the right powers. So now we get to the part where we actually set the powers to the whatever powers we got over here. So we say left dot set power, left power, then right dot set power, right power. So in case if you have 4 motors, you can just say like front left dot set power left power, and then you can say back left dot set power left power. So that also works. And then finally we have telemetry, which is how we get data, we get data from the phone. So it basically shows us what the power is, where the robot's moving and stuff like that. So it's just showing data through the driver station phone. So you have telemetry.add data, which is how you show the data. And you can say left power. And then you say comma, and then you say left power. So it shows up on the phone. Then you say telemetry.add data, right power. And then right power here. And then at the end, you say telemetry.update, which means that as the loop runs, the left and right powers change, right? So we need the update method so it actually changes it on the driver station phone. And this is basically how to do the tank drive controls using the tank drive.